Hello.
Yes, madam.
Hello. Yeah. Good afternoon, sir.
Good afternoon, madam.
Just a minute. I'm not able to hear you. Hello.
Hello. Can you hear me?
Yes, yes, sir. Good
Yeah.
afternoon, sir.
Good afternoon.
A warm welcome to you again to this session. So today's topic again is the malware signature analysis. Sir is going to give some hands-on. So it will be a very interesting session. Thank you, sir. You can take take on the session now.
Okay. So thank you, ma'am. Thank you. I think we are discussing in the afternoon, just after lunch. So I'll try to make it as better as possible. Okay.
Yes.
Um, so participants, I think you would have got the code from the organizers. You would have got two codes. One code from neural network perspective, another code from LSTM. Can you acknowledge, please? If you check your mail, you would have got your codes. Hello, participants.
Participants, please acknowledge if you have got. We have also sent it in the WhatsApp group, which you have through the for the communication. Mail. Even in the mail also, we have sent it for you. Please acknowledge. Sir is asking whether you are able to open that file. Chat window.
Yeah, there is a message from Apura ma'am. Yes, yes. Okay, thank you for acknowledging. Okay, so afternoon, what we are going to do now is we are going to extend our learning from last session on looking at how deep learning algorithms can be coded with malware signatures, right? So that means the question is, if I have a malware data, if I am able to extract the features from the malware data, how the data is available as malware data as features, is it possible for me to analyze the features and conclude that this is a malware or not? So that's a discussion for today. Last session, we had taken you through an understanding on how machine learning algorithms can be tried out. Today's session, we'll be taking you through on deep learning approaches, right? So to make it better and practical, I've sent you my code contribution. So this is from our team. So please keep for your reference and use it for your future also. It will be helping you a lot when you want to take any synthetic data related to malware analysis, right? Okay, so we'll start here. So first, what we want to take through
So
is
we are
on.
not able to see your screen. Have you shared your screen?
No, no, I've not shared the screen. I've
Okay.
not shared the
Okay,
screen.
sir.
Now I'm sharing my screen. Thank you, ma'am, actually, for clarifying. Yeah, now I think you should be able to see my screen, right? So,
Yes, sir.
what? Yeah, thank you, ma'am. Thank you. So, what we will do first is we will have an understanding on the neural network, see malware analysis with neural network, right? Then come to approaches on stochastic. Preferably, we look at deep learning. There, we look at LSTM. Right, everything you will be doing hands-on parallelly. That means the code is provided, you run it and see, you understand what is happening in your implementation part, right? So please stay with the session, and we will hope that we will make it better, right, as we go forward, right? So the first question for anybody would be is like, okay, I need some data to go to a neural network. The data is going to be a malware data. So how does it happen? As we quickly told you on the other day, the input data is going to be a CSV file like this, right? So there is going to be a lot of features, and there is an expected class. The classification here is whether it's a malware or not. So we are taking it as a binary class problem. The next step, what happens is for the given set of inputs, weights are available, and there is a bias being provided, right? Reason is the formula for a neural network general way is given input as X, W as weights. So it is X into W plus B. We will be able to get an expected W out. This is your input weights and this is your expected W out, right? Then what we want to do is we want to take what is the value that we are going to give to the hidden layer. So this is where I'm again saying you, a neural network approach differs from deep learning based neural network approaches. A neural network approach will just give you one hidden layer or more than one, but when you're coming to deep learning, it's not like that. The hidden layers will have special functionalities like convolution, pooling, like that. So here the hidden layer input is being provided. How do you calculate the hidden layer input is you have to take X, multiply with W, right? And then you will add it with WH, BH. BH is nothing but your bias. So we'll be able to get your hidden layer input. That means X into WH plus B is equal to your hidden layer input, right? Now, the next step that happens is once we have all of this with your hidden layer input, we want to find the activation function. That is done by using sigmoid of the hidden layer input. So this is your hidden layer input. Sigmoid of that hidden layer input will give you the hidden layer activations. So activations are right now available. What is the formula for sigmoid? We have already discussed. It is 1 by 1 plus exp of minus x. Okay, so sigmoid of hidden layer input will give you hidden layer activations, right? Now, the next step that happens is we want to know what is the value for the output, right? This is the class label. We want to calculate the output. So the output as such is given like this. Output is given as sigmoid of output layer input. Again, I'll say you sigmoid of output layer input. You can see very well in this slide. How will you get the output layer input is it's given as dot product of hidden layer activations into W out. This into this. Okay, hidden layer activations into W out plus B out will give you first the output layer input. On that you have to apply sigmoid. You will be able to get output layer output, right? This complete steps is called as forward propagation in a neural network, right? Now, next what we are going to go through is basically the backward propagation. That means the neural network model is not going to run for one time. It's going to run for many number of times. So every time what you will do is you will calculate the difference between the expected and the actual, right? So you will calculate that as an error, right? So the error component will be calculated. So you can see what is the error here. How do you get your error is in the previous iteration as a result of forward propagation, we got something as expected class label as 1 for the first row and the output as 0.79. So 1 minus 0.79, 1 minus 0.80, 0 minus 0.79 is what? Minus 0.79. So that is what will get filled as error, right? Follow on to that, we will calculate what is the slope of the hidden layer, right? And we will have the slope of the output layer also, right? Once we have that, we got an error in this step, no? Step 5, that is error is available here, E, right? E into slope of the output layer. That is, here it is 0.21 into 0.17, right? So that will correspond to what is the expected output here. That is D output. So that's what we calculate in the next step here, right? Okay. Then at last what we do is we calculate the error at the hidden layer. So that is the last step here. Forward, we continue the operations, right? And finally, we will be able to say what is the class label for the given input date. So this set of steps fall into what happens in a neural network here. Now let's see what happens in the terms of the code, right? Now if you can take your code that is provided for ANN, that's a code that is shared by your team members, that's your coordinators. Please take the code, right? And you have installed Anaconda already. So if you go to your prompt, if you type spider to your editor, the other editor you will get to something called as Jupyter. If you type Jupyter, you will get your editor. Reason is the code that is shared to you as a notebook file. So we are using Jupyter to open a notebook file here, right? Okay. So type Jupyter, it will get you the notebook file. Now you come down to your notebook file here. So it will open in the browser. So it's already opened for me. So it would open in your browser, right? like this, it would open in your browser. Okay. There, what you are supposed to do is you are supposed to click on this upload button, right? It will ask you the code and data that you want to upload. Now, this too has been shared to you, right? ANN final and data. If you can have a look, please check in your systems. In your mail, you would have got ANN final and next is data. Select both of it and click open. Automatically, it will get enabled and get uploaded to your environment. That means now it is locally available on Jupyter server. Rather than storing in the physical storage, now you are running it on the Jupyter environment. So you upload the file first. This is step one. Once you have uploaded the file, okay, then you can actually go down, right? You'll see your files. There you go and click ANN final.ipynb. That is Python notebook file. Once you select it, you will open the file. The file will come up like this, right? This is a data part. This is a file that will come up like this, right? Now in this, if you can walk through the code as we discussed in the last session itself, the first line of code is basically for the deep learning. So here we are using Keras. Type of model is sequential model, right? And next we are importing sklearn library. We are using a data set which is reduced form, which is data.csv. You can see here data.csv, right? This line is for normalizing the data, right? Then if you come down, we are specifying what is a training testing split. Here we are saying training testing split is 70-30. That means 70% for training, 30% for testing. This code is for defining the parameters for the Keras model, right? So here we are saying what are the input dimensions. We are specifying the activation functions for each of the layers. Once we are done, we are compiling the model, right? Here we are specifying that the metric that we want to calculate is accuracy here. Optimizer is Adam optimizer here. So once this is done, you can come down. You can specify your epochs. You can specify your batch size. Okay. Then you can try evaluating the model. When you try evaluating the model, it will show you that the accuracy is 7.36. That is 73.6 is your accuracy here, right? So this is a basic code for running an artificial neural network, right? ANN model, right? On your framework here. Framework here is your Anaconda framework. Editor is Jupyter editor, right? This is not deep learning architecture. Please understand, if it is deep learning, we have something on convolution, pooling, all that, right? We are supposed to have layers for convolution layer, pooling layer and all. We don't have any convolution layer, pooling layer and all here. We have just specified the model. We have specified the layer parameters. That's all. And we are running the model with the given data. And we are trying to see what is the performance that we get. Is it okay? Now, can I get a response in the chat box? Are you able to run, please? Okay, not able to understand. Okay, fine. Which part, sir? The code part? Vivek Gupta, sir. Vikas Jain, sir. Which part you are not able to understand? Can you put in the chat box? Hello.
So Vivek sir, you can put in the chat box.
Vikas Jain, sir. I think you said that not able to understand. Please explain again. Which part you are not able to understand, please? Hello. Okay. I will.
Vikas Jain sir, are you there?
Yeah. Okay. Jupyter. Okay. Right. Any specific reason why Adam optimizer? Okay. Fine. I'll come to the questions. I'll explain the code again. What we have written in Jupyter. Okay. Just ask me the clarification at the end again if you still have a doubt. This is the data that we are going to process. Okay. We have converted the data as a CSV file. This has now got a set of features relevant to malware part. Right. Now let's come to the code part. In this code part, what we are doing is we just want to implement an ANN model, that is artificial neural network model. So we are using Keras, right? There we have specified the type of model is sequential model, right? Layers are dense layers. If you have a doubt regarding the coding part, as we told you on the other day, if you go to keras.io, right? If you go and click get started, right? This will take you through the understanding of the environment of Keras, right? So if you are a developer, so the first thing that you would ask is how to start creating my model. So you can create everything as a sequential model. This sequential model is used whenever you have a stack of layers where each layer has only one input sensor and one output tensor, right? So the syntax would be is keras.sequential. Within that, you're supposed to specify layers.dense. You're supposed to specify the layer names if you want. And for each of it, you can specify the equivalent activation function. This is an example of a sequential model. Now, if you compare to what you see in this code, right? If you come down, we are reading the data, right? Fine, we have read the data. Then we are specifying that the training testing split ratio is 70-30. That's why we said 0.3 for testing part. That means 0.7 is used for training. Then we are creating a sequential model, right? So here we are specifying what is the layer level activation function for each. 1, 2, 3. Fine. So here, if you want, you can give your layer name also. As we have seen just now, we can give you a layer name also. You can say name for each layer can be provided here. Once you have done it, we specify by saying that we want to create our Keras model. This is a basic Keras model. Here we specify what is the loss, what is the type of optimizer we are using. See, optimizer as such, the purpose of optimizer is to handle the vanishing gradient problem. As I told you, for a neural network also, for forward and backward, right? If you can see again from what I discussed, this is the step for neural network. In this, when you go one step forward, right, it's a forward propagation. Fine. Now, when you are trying to go backward, what we are trying to do is we are trying to find the difference between actual and predicted, right? So this will lead to something called as error, right? And it is ideally possible that this might not become zero at all. But we want to make at one point that the training loss and test loss has become same. That means there is zero error or there's a minimal error in the model. That is taken care by the optimizer that we choose, right? So in our work also, where we had shared to you, we had specified that the optimizer that we can use is an ADAM optimizer. There are many other optimizers that are there. If you go to the browser and see optimizers in Keras, you'll find different optimizers. You can see here. You can find different optimizers, and each optimizer will have its own purpose. You can choose whichever optimizer you want. These are all the available optimizers. In this, we have used ADAM optimizer. If you want, you can choose some other optimizer also. Okay. Then when you come to the follow part of the code, what we have done is we are trying to compile the model. Then follow one, we have fit the model, right? Okay. So here the epochs we have specified is 60. That means number of iterations is 60. Batches, we are making it as 10, right? Then follow on, we are trying to print the accuracy of the output. So accuracy that we are getting here is 7.36 as an accuracy. These are all the precision recall values. Okay. This is an example of a basic neural network model for doing analysis on a malware data. Have you got it clear, sir? Vikas Jain, sir. Apurva, ma'am, are you clear with my answer? Okay. Vikas sir has replied yes. Apurva ma'am, are we okay? Why we are using an optimizer here? Yes. Okay. Thank you. So now can you all acknowledge how many of you are able to run in your systems? Can you just put yes quickly, please? We'll move on to the next part. Participants, I want everybody to run in your system. It's not very hard. You have to go to your Anaconda prompt, right? You have to start, as I told you, start Jupyter, right? Make sure that your browser is open so that the Jupyter also starts running. Once it opens in Jupyter, your environment will come like this. There, please go and give upload. It will ask you the file. Just upload both the files, ANN and data. It will get uploaded. Then click on ANN. Once you click on ANN, it will open in the editor like this. You will have a run button. Click on run button. It will show you the output. I'm waiting to see some status in the chat box. People who are able to run the output, please. So big silence. Can you unmute and talk, please?
Participants, please message in the chat box if you're able to do. Sir is waiting.
Yes, Kirtana ma'am, I think yes, you put that means code is running, right? Can you say code is running so that it's happy for us? From our side, the effort is matched. Yeah, code is running. Thank you, Kirtana ma'am. Thank you. Others, please try running the code. It is for you, and you can keep it for your reference. Code is running. One more person, Pravina Banu ma'am. Okay, fine. Praveen. Okay, Vinita ma'am, code is running. Can we take? We'll wait 2 minutes, then we'll start the next concept. Meanwhile, if there is any questions from others, you can ask the questions. Only when you run and see, you'll get the comfort, and you can use this code for your work also, right? Later. Any more people? The code is running. Can you put in the chat box?
Participants, if you have any questions to sir, you can ask. You can unmute yourself and ask the questions.
Okay, I'm getting one more response from Geeta Nandakumar ma'am. Code is running. Okay, good. So thank you for doing the support from your side. Now we'll move on to the next concept. Now our next discussion would be is like, okay, we are done with using a neural network for analyzing a malware. Now, what if we want to use a deep learning architecture for analyzing a malware? That's the next question for all of us, right? Okay. So there are many deep learning architectures, as we have told you on the other day, and almost all deep learning architectures generally rely on the concept of using a layered model. Like what your neural network says, no, layered model will be there in all deep learning architectures, but names will change for the layers. That's it. Now, keeping this as base, we can look at many architectures, but for our discussion today, we will look at two architectures. One is from your concept of LSTM, and the next architecture we will look for is from the concept of GRU. Okay. Uh, so why are we using LSTM? That's a next question from people's side, right? So first point is will be an answer for you. RNN will have problem of vanishing gradient. Okay, right? So since vanishing gradient problem exists, there is a lot of possibility that your information may get lost. What is information is you are having data as an Excel sheet, right, with lot of values. But what is processed from that is information, right? So since RNN has a problem of vanishing gradient, it is likely possible that the model as such may lose some data. So that's a problem with RNN. So because of this, people suggest that you can go for LSTM. So LSTM introduces a concept of saying everything is represented as a block. If you go back to your RNN, everything is represented as a cell. Okay, everything is represented as a cell. But if you're coming to the case of LSTM, it is represented as a block, right? So blocks as such will store the data, and the chance of saying that the data will get lost or it will forget the data is not there if you're going for LSTM here. That is the reason people go for LSTM architecture. Now, this is how this is how your LSTM works. It says that everything is represented as a cell. So there'll be something called as input gate. There'll be something called as an output gate, and there'll be something called as a forget gate. Input gate allows you to take the input to the cell. Output gate will perceive the final output. If you don't want the data, you can forget it by using a forget gate. So the three gate names are input gate, output gate, forget gate, right? Models like this are slightly abstract. Abstract in the sense, at one point you have to believe, okay, it is working, right? You should not ask how it is working always, right? So just first see the mapping of the model, then related to the data, you will accept, yes, it is working well. Fine. So input gate, then you have output gate, and third is forget gate, right? All this together is called as a block. Can you see here? All this together is a block. So LSTM is popular because it says that I'm representing data as a block. So the chance of losing the information is very less if you're going for LSTM here. Right? Now, let's come down to the parameters that we have seen here. First one that you see is W, right? So W as such here is nothing but the weight, right? Weight will be part of every interconnection here. So weights, that is W, you can see for every data. And next one that you can see is something called as the activation part. So there will be an activation for one unit cell with the other unit cell, right? And last to be understood is the input gate, forget gate, and next is output gate, right? Okay. Now, this notations has to be remembered always. The first one is a notation for input gate, which will be as I. And next is phi, which is a notation for forget gate. And this notation is used for output gate, right? Equivalent weights also will come. Can you see here? Wi will actually indicate the weight for the input gate, and similarly for your forget gate, and similarly for your output gate, you will get your weights. So the weights are indicated here, right? The next theory you should keep in understanding is every cell here will have a state, right? That state is indicated as like this. S suffix C, right, is a state for a particular cell, right? Last will be the activation function for the gates. We have said that we are using something like ReLU if you're going for deep learning architecture. Here it's not compulsory that you should use a deep learning architecture of LSTM with ReLU. You can use other activation functions also, right? Now the last in conclusion is I will become the number of inputs. K will become the number of outputs, and H will be the number of cells in the hidden layer. Okay. So I, K, and next is H, right? So when you come to the case of LSTM, it has its own formula here. You can see the formula for the input gate, formula for the output forget gate, formula for the cell, formula for the output gate, formula for the cell output, right? For each stages, right? All this are the formulas which people have developed. So anytime an LSTM is working, right, it will use these formulas to preserve the information, right? Now, what you should have got from theory is there is something called as input gate, forget gate, and output gate, right? There are formulas to carry the information for each of the cells at any point of time. Now, with this as basics, we will come down to the part of LSTM. Yes. Now, this will become more clear from this part. See here, as what we told, we are having a forget gate, input gate, and an output gate, right? So now, every time what we want to do is, we will actually have data to be stored. The data will be stored as part of the cell, right? But here what they say is, they say that we will maintain two types of memories. One is actually the cell state, and next one will be the hidden state, right? So the cell state is a long-term memory. Reason is, see, when you are giving data, now you are giving first row of record. Now what is there in the cell? It has first row of record. Now I'm giving second row. What is there in the cell? First and second. Now I'm giving third row. What is there in the cell? 1, 2, 3. So the cell state will have long-term memory. That means the data will be keeping on adding to a cell state. But when you come to the hidden state, right, it will have only short-term memory, right? Because it will not store as much of data that is stored in the long-term memory here, right? Now, this is the formula here. You can see to the input, right? If you can see, every time the input will get updated, right? So 1 minus update will be forget. Can you see here? 1 minus update will be forget. The next, in your LSTM, we will use tan-h activation function, right? Okay. This formula will be resembling to what you would see in a GRU, right? This is also what you see in the GRU. The next one is where we will try to calculate what is a value for the forget gate, right? So first one that you have calculated is for the input. Now what we are calculating is for the forget gate here, right? Last one is the output gate, right? Which you can see here. This is unique. This will not resemble to GRU, right? Now, once you have your input, forget, and output, together we apply an activation, right? Fine. So, what I'm trying to conclude here is LSTM mostly resembles in GRU, but LSTM has its own characteristics like an output gate, right, is one key difference for LSTM compared to GRU, right? Now, this I want everybody to listen, please. This will be a quick summary for architectures that you would all come across. CNN is one architecture which is more spoken from the people side, right? It's very popular and it's very powerful compared to RNN, right? Okay. CNN as such, we actually say that we need to have finite input and finite output, right? But RNN is not like that. The input length can vary, output length can vary, right? The next one, CNN is actually a feed forward model. That means we have a forward propagation, we have a backward propagation, right? But RNN is not like that. RNN actually follows through a looping network. Reason is in RNN, the neuron is called as a recurrent neuron, right? Then CNN is used for video processing and image processing, whereas RNN is used for time series data, right? Then CNN will have concepts which you would have seen from the animals, that is where we say that the neurons are getting triggered. Same way CNN also says that neurons are getting triggered. Now RNN is not generally like that. It generally works on specific applications like speech analysis and text analysis, right? This is between CNN and RNN. Now come to GRU and LSTM. Less parameters in GRU, more parameters in the case of LSTM. Less memory for GRU, but as such, LSTM is not like that. We told that you have a long sequence data, the size is keeping on increasing, then the possible solution is to go for LSTM. GRU is very faster in execution and trains also faster, but LSTM is slower but trains slower compared to the case of GRU. Now, this factor will allow you to accept that LSTM is better. GRU has less accuracy, LSTM has got more accuracy, right? Fine. So last one is simple. Any memory computing problem can be taken in the case of GRU. Same is applicable for LSTM also. So conclusion here is LSTM has got higher accuracy compared to the case of GRU, right? So when you want to compare any of the algorithm performance, as we told you in the last class, we can use confusion matrix, right? We can use accuracy, we can use detection rate. Formula is there. Detection rate is like true positive divided by all variations of positives and negatives. That means TP plus FP plus FN plus TN. Then next is logarithmic loss. Then you can calculate the sensitivity, which is true positive rate, TPR, and specificity, which is false positive rate, that is FPR, right? And you can present it using a confusion matrix also like this. The other metrics are precision, recall, F1 score, then there's something called as ROC is there. Then people can actually use precision recall curve is also there, right? ROC is most commonly used by people. Reason is like this will allow us to say the probability of data nearing to a class conclusiveness. What I'm trying to say is if you give a test data, if you have want to get a conclusion that it is probably falling into class 0 or class 1 or class 2, there the important parameter that you can evaluate would be an ROC curve, right? So this is the theory part for LSTM. Any questions from the participants? Any questions from the participants? Please put it in the chat box. There's no questions. Please put no.
Any questions, participants? Please respond in the chat box. You can also unmute yourself.
Okay. If there's no questions, you can put no at least. We are now moving on to the coding part next. Okay, do we need to measure all the 10 parameters? Not required actually. Confusion matrix is very important. It should be used for every problem, right? Irrespective of whatever problem it is, confusion matrix is very, very important. Then you can choose between precision recall or accuracy. For example, some problems will say that I want to accurately predict. Some problem will say that I want to know the number of misclassifications, right? If you say that the problem has to accurately predict, their accuracy is a solution. If you say that I want to calculate the total number of misclassifications, there you can go for precision recall, right? ROC curve as such will be used when compulsorily if you're coming to the case of deep learning approach. Have I answered to your question, ma'am? Kirtana, ma'am? Yeah, okay. Okay, can you just repeat about ROC? Yeah, okay, no problem. We'll discuss. Yeah. See, actually, ROC curve, why people are very much required is why we are going for all this machine learning approaches or deep learning approaches is we want to reduce the number of false positives, right? We want to reduce the number of false positives here. So here ROC curve will be the plot between true positive rate and false positive rate, right? TPR versus FPR. We can see here y-axis will be TPR and x-axis will be your FPR here, right? So at the lowest point, that is 0, 0, if you can see here, the threshold will be 1, right? That means in this case, what we are saying is all patients are not having a heart disease, right? At the highest point, that is 1, 1, at the highest point, that is 1, 1, here if you ask what is the threshold being fixed, right? The threshold is actually 0, right? It means that all patients have been correctly classified, right? So rest of the values are, what are the values is the values for your FPR and your TPR, right? Whose threshold values is between 0 and 1, right? Okay. So if you assume that we are getting FPR close to 0, this is your FPR, right? Your x-axis is FPR. If you come closer to 0, what are we achieving is your TPR is also becoming 0, right? Okay. So the model will predict correctly the patients. So ultimately what we are saying is, the when we are saying that the TPR is getting closer to 0, we are reducing the number of false positives. So what we really want is, we want to have a model which will reduce the number of false positives. So by plotting a ROC, you can find an ideal value at which the true positive rate is better and false positives is getting reduced. Madam, have you got the answer? Okay, okay, ma'am. Thank you. See, ideally, whatever may be the problem, our question is, are we reducing the number of false positives? That's all. If you are reducing the number of false positives, our model is perfect. Even you can use k-means and claim that false positives is reduced. So I'm using k-means and KNN instead of CNN. Any other questions from participants? Okay, no questions. Now we are going to the next code, right? Again, if you can go back to your file that has been shared, right? You would have got a file which would speak about LSTM. You can check your mail. Can we use clustering algorithm to label the data? Yes, ma'am. You can use clustering algorithm to label the data. I think I've shown you on the other day also of using k-means. I think I'll run it here again. This is a sample code of k-means with KNN. Data is provided, as you can see here. No, you provide your data, which is a CSV file, right? Now, once you run through your k-means, right, by specifying the number of clusters, automatically the data will get labeled with a particular number of clusters. So here I have to start from beginning. So yes. So first I have to invoke the k-means classifier, right, from sklearn. Then I have to read my data. Then I have to specify my number of clusters. Then I can actually come down and see the performance. Here the performance I'm evaluating using KNN under the supervised model. For unsupervised, I've used k-means here. But my question is, do we need to validate the result? You're asking, do we need to validate, or you are asking, how do we validate the result, ma'am? So, Kirtana, ma'am, your question I'm not getting. Are you asking, how do we validate the result?
Yeah, my question is, uh, sir, after clustering algorithm, we will get some result. But how do we know that the result what we got is right or wrong, or whether the program, how the program is, the result is right or wrong? Do we manually we need to validate the result, or how how it
Okay.
is.
Okay, good question. Actually, one way of doing is like you have to look for data which is already labeled, right? If you go to your internet, I think I told you on the other day, right? IoT
Yes,
botnet data set,
yes,
right?
yes,
You
yes.
have to look for data set which is having a label. Or if you don't have a label at all, right? What you know is some features. You have come to a conclusion that okay, I've used some features, right? But for that, there is justification from somebody in the paper saying that I did an analysis with malware. My features are F1, F2, F3, F4, F5. So you also made features, right? But you don't know whether your clustering is correct. That's your question,
Yes,
if
sir.
I'm right.
Yes, sir.
There,
Yes, sir.
what research generally says is research says that you try with some other algorithm which is actually used for your classification, right? So you can try with the fuzzy C means, right, and see how much is your classification label coming up. If it matches closer to what is coming in K means, that is okay.
Okay.
Huh? Or
Oh,
if you get a question saying that I have a doubt, okay, how do I fix my value of K? When I say 2, it's okay, 3 is also okay, right? So there, as I told you, you can go to algorithms which is there for fixing the value of K. So based on your data, you can fix your value of K using your elbow methods.
okay.
Using this, you can find what can be the best value of K for your data. Then
Oh,
when you run K means, your clustering is correct.
okay. Okay.
Okay,
Sir,
ma'am?
if we got say any doubt when we are implementing, can we approach you for clarifying the doubts, sir?
Yeah, sure, ma'am. You can reach me, no problem. As much I know, I'll surely clarify.
Yeah,
You can reach
because
me.
I yet to start to that particular point. So right now I don't have the clarity of that particular question. Uh, uh,
Ma'am,
after
I will understand your question like this. Your question is, if I have n features in malware, I have run K means, right? K means is like a black box, right? You give some
yes,
data, it will classify. Am I right?
yes,
Yeah.
yes, yes.
So now your question is like, what was my class label, whether it is correct or not? For
Yeah.
that, usual state of research, what people used to say is you ran with K means. No, you run with one more other unsupervised model. Let's take a fuzzy C means,
Okay,
right?
okay,
You get the same class label, you can conclude, yes, it is correct.
okay, okay.
Okay, right? Otherwise, no. I want to just go one step forward and think about my value of K itself because I
Mm,
don't know my class label, how much whether it is two class or multi-class. There,
mm,
what possibilities? Use an elbow method. Elbow method will allow you to fix your value of K on your data. Then when
o-
you run your code, no, you are specifying number of clusters, n clusters equal to 3. If the
mm,
elbow method says it is only 2, fix it as 2.
okay,
There you can defend your research or your project saying that, yes, I went through a study of elbow, then only I fixed the value of K.
okay.
Okay,
Yeah,
ma'am?
okay. Clear, sir, but not able to because right now I don't have that particular data, so I have that full confusion. But
No problem, ma'am. As you go forward, you please reach me by mail. I'll share you my number also. Please reach
sure.
me by mail and our number. Surely, whatever I know, I can give you my support. No problem.
Uh, Thank you very
Okay,
much,
but,
sir.
but
Thank
when
you.
you do your model part, as I told you earlier, you should spend some time on the data. You should fix this is my data that I'm going to use. Last time I showed you, no, on the IoT
Yes.
Fortnite data set, we have took only some features which we feel is correct. Like
Uh,
that, you should fix your data set. Your data set, once it is ready, then you can play with your models.
okay. But is there any method to select the features, sir, other than like a
It is domain.
PCA?
It is domain
Uh,
knowledge of the problem. It's domain knowledge of the problem, ma'am. That's all.
okay.
Okay. See, for example, you are working somewhere, no? Am I right?
Yes, sir.
Yeah, if you take your college traffic, you ask your server admin, he will give you the college traffic as a network log, right? Ma'am?
Okay.
It will come as a network log. There you have to write a code and understand what is the meaning of the network log,
Okay.
right? There, if you start asking what can be an attack, right? It can
Mm,
be a host or a network level as we spoke. There you should ask a question if it is a host level attack, which will be affected. It is a node level details. With the network
okay.
level, it will affect the router ID also, right?
Okay.
So you have to write rules for your attacks.
Okay.
Right? The rules will help you to understand that you are able to have a analysis done properly.
Mm.
So first
Okay.
is data, then second is understanding the meaning of the data, third is developing rules. Rules will allow you to possibly specify the class. Then
Okay.
if you say F1, F4, F3 together is all
Mm.
like this, it falls into one attack, right, ma'am? So now
Yes.
you are able to decide your features which will participate to that attack.
Okay.
This is how you should do.
Okay. Thank you very much, sir. This particular step really uh, it is like a high opening for me. It's like
Sure, sure,
how
sure.
to approach. Thank you very
Yeah,
much,
this
sir.
is how we are doing actually, because as I told you, we already have a funded project from IBM with my team. So whatever
Okay.
we are learning, I'm trying to share it to the members here. That's all.
Thank you very much, sir.
Yeah, thank you. Thank you.
Bye, sir.
Yeah, thank you, ma'am. Bye. So going forward, now it is like, okay, we will try to run with the code, right? We have now seen LSTM. We will try to run it with the code. So if you can go to your Spider environment again, you will get your Spider environment. Now what we have shared to you is a Python notebook file. Please open Jupyter, right? So in this, if you can see the code, right, what is shared to you, you will find final variant LSTM final. Participants, final variant LSTM final. Please load that file. We are discussing after lunch. Please don't forget the step. Go back to your Jupyter, click on upload, right? Upload the file, right? Final variant LSTM final. Okay. So how many of you have uploaded the file? Can you respond in the chat box?
Participants, please respond in the chat box.
Done, sir. Okay, Apurva ma'am has said yes. Okay, now what we are going next is we'll go forward to understand how do we use LSTM for malware analysis. Here, as such, we are using a data set which is released by Kaggle, right, for malware analysis. So if you can come down, this is a code that you also got. So first we are loading the packages. Then what we are doing is we are trying to load the directory from Kaggle, right? So next what we are saying is under Kaggle, what are all the data that we want, we are trying to specify. All this are data that are provided by Kaggle. I think one ma'am was asking about the features and data. This is also a very good data set which people can use for malware analysis. If you go and type no, right, it will actually take you to malware detection URL. Under this, you got the data sets, whatever we are using, right? So here, what are we doing is we are trying to access all the data sets. So first we need data, then we need Kaggle data, then we need a training data, and we need a testing data. Then next step would be is like we want to load the data. So first we are loading the data, right? Then we are trying to use classifier. So here we are trying to use import extra trees classifier. I'll come down to this later, right? What is the use of this is it is like a decision tree classifier, right? Decision tree classifier. So we use the method. Here we specify the number of estimators, right? And we say what is the type of criteria, that's the entropy value. This is related to what you would have all learned in theory under something called as decision trees. You can go back to machine learning or data mining subject, you would have learned something called as decision trees, right? So when you learn decision trees will ask you that give me some data, but give me the number of features, specify how will I associate the features. So there, one way of associating the features will be is entropy. I think people can see here, right? Entropy part, right? So here again, we are specifying the same thing here. we are trying to have entropy as a parameter for extracting the features from your using a decision tree classifier, right? So all this is a code for decision tree. Then this is all the results, right? Now next, what we are coming down is more into the this part is done. Please see here, this part is done, right? Okay, so first with decision tree, the number of features in the original data set is 15. The important features extracted is 18, right? So important features are extracted using a decision tree. How are we extracting? We are extracting using entropy parameter, right? So the criteria is your entropy parameter, right? Then what are all the features that we have extracted is all these are the features that are extracted, right? Then coming down, we have tried to transform and we are trying to print the feature values for each of the rows, right? Okay, right. Now, next what we are coming into is into the deep learning part. Till here, any doubt? Now, what we have walked through in the code is using a decision tree for the given Kaggle data. Any doubts? If you have any doubts, please put in the chat box. If you don't have any doubts, please put no doubts so that we'll go to the next. Participants, if you don't have doubts, please put no doubts or none. Clear. Okay, thank you. So now what we are going next is we want to come to the LSTM part, right? Now we want to compare the architectures. So here we are using LSTM and we are trying to compare it with GRU architecture. LSTM with GRU, right? Okay. Now, when you want to create a model, as far as your GRU is concerned, so GRU as such is very interesting. We will take a quick look at GRU so that now you are able to compare both the architectures, right? LSTM, just keep your keywords input gate, output gate, forget gate, right? As far as your GRU is concerned, what GRU will say is GRU stands for your gated recurrent unit, right? So how does your GRU work? It's like this. Yes. Yeah. So here the gates as such will be understood as update gate and next is called as reset gate. Okay, update gate and next is called as reset gate, and GRU is also a gating architecture, right? So the use of GRU is again either it will keep the information or it will discard the information, right? But LSTM, what does it do? It either keeps it or forgets, right? Okay, here we say it is kept or discarded when you come to the case of GRU, right? Now let's come to the gates here. Update gate as such, what it will do is it will try to have values between 0 to 1, right? Which will be multiplied with the given input data that you provide, right? And it will either give you either a 0 or it will give you as 1. A 0 in the gate vector, right? That is your update gate or the reset gate, right? Will indicate that the values are either used or whether it is unimportant or whether it is discarded. Now, when there are gates in the model, that's your GRU, there is a need that the gate has to have a reset operation. The reset operation will be done by using a formula like this, right? So the reset operation will allow you to reset the gate. So we have a reset gate here. So we want to reset it. So how do you do the reset? Just see here. Here you can see a dot product. Can you see? You can see a dot product here. So what is coming in your dot product is hidden state, that is h suffix t minus 1. Please listen, you can get the clarity. Hidden state t minus 1, right? Multiplied by, right? Hidden reset weight, that is w, right? Together you will add it with, right? W input of the reset, right? Multiplied by x. What is x here? That is your input here. That is x suffix t. On that, you apply sigmoid. Fine. Once you apply, then you'll be able to get the reset value for the gate. Right? Okay. Now this will be taken forward and we will apply a tanh function. Can you see here? We'll apply a tanh function, right? And this will take you through the backward propagation process, right? Now, this is how your GRU works. Now, our discussion is why are we talking about this here is we want to compare with GRU architecture. Can you see? We want to compare it with GRU architecture. So in the import, we are given one as GRU and other one we have given as LSTM, right? One is GRU and next is LSTM here. Now, let's come to this next part here. We want to specify the model. So specifying the model is direct. We can say it is a sequential model here. Every model is here in deep learning will be sequential one. When we are trying to use GRU, our discussion would be like what are the units that we want to specify. So the units here will be 15 by default. Return sequences will be specified. For the first layer alone, we'll specify the shape here, right? So shape is very important here because without a shape parameter, your GRU will not work, at least for the first layer, right? Then rest of the layers, your shape will not be specified. We'll specify only the units, right? Then at last, as we did for the earlier architecture, we specify the optimizer to be Adam optimizer, loss to be what type of loss that we want to provide, and we'll specify the metric for evaluation. Metric is nothing but accuracy here, right? Rest of it all is same, right? Now, the next would be is like running through the model here. I will show you the other part. That's from the LSTM part. 1 second. Participants, 1 second. Yeah. Okay. Now, where we stopped is from this part. That's your GRU part, right? Now, the next one that we want to do is go through the training and testing. So we do through the training and testing here, right? The next part is where we are trying to compare and present the results, right? So since GRU is again an LSTM based model, whatever results that we get here will be same resembling to the GRU and LSTM part. So for every layer, what is the equivalent output shape and what is the parameter that we are evaluating, right? Then this is with respect to total number of parameters, and this is trainable number of parameters. That means all features are taken here. So total number of features is 5146. Trainable features is also 5146. This is for every epoch, right? How does it run? So it will finally say the overall, yes, it will show you the overall accuracy for every phase. So the accuracy that we have got for training your malware classification here is 0.89. Okay, that is 89% malwares have been classified correctly here, right? Now, if you come down to the plots that we can show, one plot that we can show would be for the accuracy part. So for your set of logs, what is your accuracy that we get? We are getting plotted here. So the accuracy is improving from 0 to it's increasing high. So same thing here. This is for the validation accuracy. Don't worry about this number 290 here, 2 here. It is something like you have to look at your accuracy part here. So the validation accuracy is increasing from 0 to higher value. That's all from here. Any doubts? Participants, any doubt? If there's no doubt, you can at least put no doubt so that we are clear. No, sir. Fine. Okay. So when you want to analyze any sort of data, including a malware data, you can analyze the data by specifying the features, and you can also say that why the features are very important, right? So in this, LSTM is a good way of doing the problems. So when you do LSTM or GRU, both resembles the same in the way the model is created, right? Now the last that I would like to speak to people would be is on understanding the same data as a model based analysis. Okay. Now I would look at inputs from all of you, right? This will be a close of an interaction session where I would like people to answer to me. How do they understand this? Okay. Now what I want to discuss is on this is now coming up like anything, right? Formulating a hidden Markov model for network security problems. HMM, hidden Markov model. Right? So quick discussion here. When we have a set of states, we can call the states to be S1 to Sn, and the process will move from one state to another state, right? And here we define something called as a Markov chain property. When you say something called as Markov chain, it means that it is following a Markovian process. What is Markov chain property is the probability of a given state, right, is dependent on lot of other states, right? That means the other states can be the states in the same feature set, right? We need two probabilities. One is transition probability, and next one is going to be initial probability here. So let's take through an example and then we come to your discussions for everybody here. Let's take we want to form a Markov chain, right? There will be generally two states here. One state is called as rain, other state is to be dry. This is for a weather situation. So transition probability is moving from rain to dry. Or somebody would say that I want to go from rain state to same in the rain state. It is 0.3. Rain to dry, it is 0.7, right? Or somebody says, I want to change from dry state to the rain state, it is 0.2, right? And this interpretation people will know probability to stay in the same dry state is 0.8, right? This is an example of Markov chain here. Now, the discussion here is how do we calculate a probability of a sequence, right? Assuming that the states are available, okay? Now, let's take all of your discussions here. So can you just put an yes in the chat box, all of you, so that I understand everybody's there, so that I call out somebody, people say yes or no something. Participants in the chat box, can you all of you put yes? Just for all of us to know, okay, we are all in the session. Or at least a hand symbol. Yeah, hand symbol from all. As we ask our students, right? Quickly say, put your hand symbol up. There's only one hand symbol coming up. Others, no hand symbol is coming up. Okay, I think you're all teachers, right? So I need not compel you to do an response. Right. Now, what I want to just discuss is maybe it will all help for everybody, right? This is a good working area now. HMM for malware analysis. It's got very limited publications. In fact, somebody is in your research. I would request you to see how HMM can be taken for malware analysis. Our team also, we are working on HMM with malware analysis. So let's see an example here so people can support with the discussion, please. Now, let's take it like this. See, first, when you talk about HMM, the keywords, right? What HMM says. Let's see the keywords. Keywords are state, hidden state, right? State and next is hidden state. Okay. Now, if you talk about features, F1, F2, F3, and you say that there is a class label for it, right? There's a class label for the data. Whatever you're working on, no? There's a class label for the data, right? So here, somebody would start argumenting saying, what can be called as states? Okay. So before we go to what is states, let's take it like this. I have a network log, right? Now my network log values are like this. 23, 33, 34, 12, 44, 22, 12, 122, 122. Okay. Now the question is like, what is a class label? There, as one of the participant ma'am was asking, I use a k-means. I got my class label here. Class label as 0, and I got as class label as 1. Now, if you ask yourself what can be state for a HMM, one answer of talking about state would be is you can directly associate it with a class label, right? And you can specify what is a state. So what are your states? There are only two states here, 0 and 1. Please listen. Okay, this might help each one of you, right? This is how we are taking through in the research. Okay, so if you ask what is a state, you would say 0 or 1, because state is either changing as 0 or 0 to 1 or 0 to 1 and so on, right? Okay. Now, if I ask you what is the transitions, right? Then you would say that a transition is from 0 to 1, right? And a transition is from 1 to 0. A transition could be from 1 to 1 also. Like for example, I'm getting a new data, right? It still remains as 1. That means what? The transition is 1, 1, right? Okay. So 0 to 1, 1 to 0, and next is 1 to 1. Now, what is the transition that I missed? Can anybody say in the chat box or unmute and say? Participants, what is the transition I have missed? Can you put in the chat box or can you unmute and say, please? 0, 0. Good. Okay. Arvind Kumar sir. Yeah. Okay. Good. So the transition I have missed here is 0, 0. Right? The transition I have missed here is 0, 0. So for each of these transitions, right, I'll have to come up with some sort of a probability. That means I need a transition probability here. Right? So my transition probability can say, if I look at this here, right, what are the probability sequences for this? This is 1, right? This is 2, 3, and this is 4. 4 occurrences. I think people can understand, right? 4 occurrences. Maybe I'll make it better. I will just add one more, right? I say it is 5. I think you can understand. 1, 2, 3, 4, 5. 5 occurrences. So my transition probability of 0, 1, right? It is 1 out of 5. So my transition probability, I'm doing a handwork. This can be coded always, right? So this you can call it as 1 by 5, right? Okay. So what is the transition probability for 1, 0? Participants, you can unmute and say, or you type in the chat box. What is the transition probability for 1, 0? Same, yeah. You will get the same thing. That is, it is 1 by 5 because this is one occurrence, right? So it is 1 by 5 equal to 1 by 5. What about 1, 1, 1, 1 transitions probability for it? 2 by 5. Okay. So it is going to be 2 by 5, right? 0, 0, 0, 0. 3 by 5. 0, 0, 3 by 5. How do you say it is? 0 stays in 0 is 3 by 5.
Sir, no. That was I had given it for the 1, 1, sir. Like it was 2 by 5. So,
Okay.
but how was it 2 by 5, sir? I thought it was 3 by 5, 1, 1. So the
Yeah. Hello.
yes, sir.
Yeah, ma'am, I'm looking at transition, right? 1,
Huh?
1. State transition, I'm considering like this. 1 and stays in 1.
Okay.
So it is one time it is staying, another time it is staying.
Okay. Got it, sir. Got it. Clear. Got it, sir.
Yeah, fine. 0, 0.
Yes, it is 1 by 5.
So it is. Now, if you sum up all these probabilities, it will become 1. Okay, right? Now what we got is a transition probability. Now this can be expressed as a TPM, as your transition probability matrix, right? Okay. Now the next challenge here in this model would be is finding the hidden state, right? So hidden states as such, what people talk about is one way of interpretation is states which will influence classification, but they are not directly participating in classification. I'll again repeat, states which influence classification, but they do not directly participate in classification. So it is something like, if you take this class value here, there are some other states which are called as hidden states, which I called as H1, then I called as H2, and so on. So finding the hidden state values is a challenge. So which are all the hidden states from your data has to be taken, right? Once you find your hidden states, then what you can actually find is you'll be able to find the entropy of error, right? So here you can actually use entropy for finding the error value, right? So once it is done, you can actually take your model and you can evaluate it for a longer sequence data. What I have walked through is 50% of the steps, right? But formulating completely, it is from your own perspective. You can think about what can be state. Somebody will say that this is state. Okay, states are transitions, but some people know what they will say is this is state. F1, F2, F3 is state, right? H1, H2 is hidden state, right? F1, F2, F3 is state, and H1, H2 is hidden state, and this is class label. So given a set of states and given a set of hidden state, I'm interested in finding the class label. That's other way of looking at the same data, right? You can look from your side and see how it can be done, right? So for this, if you go to the internet and see HMM Learn, okay? HMM Learn, there'll be a library for HMM Learn. This is implemented in Python. So you can use this for running through a sequential data like what we have now in malware, and you can classify and predict the data. right? So I'll show you one which we have started. We are not completely done with it. Partial success, we can take it like that. But I'll show you what we have done. Yeah. So HMM. So this is the data, right? This is the data of the features, right? So here we have used KDD dataset. So first what we are trying to print is the occurrence for each of the features. Then follow on, what we have done is we are trying to use HMM learn directly. HMM learn, as I told you, it's a library for doing classification using hidden Markov model. And we are able to classify the attacks. It automatically classifies, right? So it's a binary class problem that we have provided. So some labels will be classified as normal, some labels are classified as attack, right? The other way of doing the same thing is you can implement by using a Gaussian HMM also, right? So here people talk about linear, non-linear based model. Same way here, no state-based HMM. People talk about normal HMM, Gaussian HMM. So with Gaussian HMM also we have tried to run, okay, and we were able to get the influence of features, and we are now trying with the attacks. You can see here, right? This many records have been classified as attacks. This many records have been classified as normal, right? So this is what we have tried from the HMM side. It's not fully complete, but partial success, as I told you, no. But the formulating a HMM for your malware analysis data, you can also do some justice in your research, right? You can see how HMM can be formulated for a malware problem, and given a malware data set, how can HMM work, right? If you do, surely it will have good contribution in your research. Okay, that's my suggestion. Last, which I want you to get with this, now there's a lot of work coming up with respect to what to say, image-based malware analysis, right? So image-based malware analysis. Right? A lot of research papers are coming up for analyzing malwares using images. You can see here, no? Can you just see? A lot of papers have come with respect to analysis of malwares using images, right? That's a good scope of research coming up here. So here also, what you can actually do is you can try doing a lot of justifications. So if you want to take something like this from the image perspective, then the thought process would be like you have to take data, which is images. You'll have to process the images, and you will have to say that I have developed some sort of uh, weight matrix. The weight matrix will be used for analysis, right? In this, I will show you one thought process. It might help you if you want to go for image-based malware analysis, right? Okay. So I'll open you the code from Spider. Meanwhile, any questions from your side, participants? I'm coming to the last part of my session. That's image-based malware analysis.
Participants, if you have any questions, you can ask, you can unmute and ask, or you can type in the chat box.
Arvind Kumar sir says no. Okay, sir. Just give me a second. Edit is getting open. Take few seconds for Spider to come up. Just give me a second, please.
Hello, sir.
Yeah, now it's okay, fine. Participants, now I'll just quickly take 5 minutes. I'll explain you how to do image-based malware analysis. So it is like if you have an image, you feed it to a deep learning architecture, you can actually learn the weights of the image, right? So how do we do it is like, let's take, we have a code. I just open you the code here. Okay. So I'm just uploading a code. So the same concept here, the input data that we are providing is not going to be here features, but instead what we are trying to provide is going to be an image here, right? So I'm loading both the codes. Yeah, I'll finish in maximum 5 to 7 minutes from here, right? So now codes are uploaded, right? Now what we want to do is we want to do a malware based image part, right? That means we want to see how images can be tampered or images can behave as malwares, because images also carry information which can be signatures as part of the malware part. So to do it, what you can do is you can actually write a code which is built on Python with same Keras framework. So once you run the code, what it does is it tries to take the weights.
Sir, your screen is not visible. Are you sharing your screen?
I forgot. 1 second. I'll share. Are you able to see the screen, ma'am, now? Hello.
Not yet, sir. Yeah, now it's visible.
Okay, fine. So what I'm doing is I'm actually loading a code that is already available from my side, which will actually take an image and it will load the weights, right? So the purpose here is like if you have an image, if you feel that the image is different from another image which has a malware information, how do you check it is you can actually check based on the weights alone, right? Weights can be a good way of doing it, right? So the same principle is followed here. So we just have a model created by using a Python code. And what the code is supposed to do is the code is supposed to load the weights from the original image, right? Okay, so it's uploading. Fine. The code is getting uploaded first to the Jupyter environment. Right. Now, when we try running the code, right, what will happen is, I'll just say you as a process, it actually takes an image, it performs convolution, it performs pooling operation, then it creates a model file, right? So your model file as such will look like this. People can see here, right? A model file will be looking like this. What will be there in the model file is it will actually create the weight values with respect to your data, right? Your model file will actually create your weight values with respect to your data. So I was running multiple applications, so it's taking little time, right? So the advantage here is you can assume that the model file is uniquely speaking the data, whatever data that you're working. Here the data that you're working is an image which is not having a malware. Right? What you're speaking about here is an image which is not having a malware, right? So when you want to take another image and say that whether it has a malware or not, you can actually cross-check here just based on the weights file alone, right? That's your model file alone. can allow you to check whether it has a malware or not. So the conclusive sentence is, take some images, right? And you want to check whether the image carries a malware or not. Take some other image which carries a malware. I think you know what is malware for an image, right? The image as such will get modified by having some more information in the image part, right? But visually you will see only image. So first take your training set images and run with your model, create a model file. Then give your test image file. When you give your test image, it will be able to say whether it is a malware or not, right? This is now the current state of research that has started working with malwares, where the malware data is not just data from the network. The malware could be again an image that you can process, right? In this, what I will suggest to people as a research direction is, if you go to the internet and see, you will find something called as cryptonet. People can go to the internet and see, you will find something called as a cryptonet, which I have talked to you earlier also. This cryptonet implementation also you can use for seeing how it can be connected to a malware scenario, right? Because if you see this cryptonet model, right, on the internet, they will speak about cryptonets, how cryptonets work, right? Now, if you see through the understanding part, the discussion will say very clearly that there is a data that you are trying to provide, and the data is sent from sender to receiver, right? Now, our whole question is about how the data is sent from sender to receiver. If the data can actually be a malware, right? If the data can actually be a malware, how can your model detect it? That's our question here. So if you come down to this, yeah, 1 minute. Yes. You can use this also. See, if you come down to this, they will actually say that there is a sender and receiver, and the sender and receiver is trying to send data, which is an image. A third party attacker is trying to access the data and try to decrypt the data. So there you can again put the context of malware and assume if the sender sends an image, the attacker is taking that image and convert it as a image which is becoming a malware, right? Can you decrypt it and find it using a deep learning model, right? That can also be a good state of research, right? People can try on this directions. That's all from my side. So today's discussion, I want everybody to get through with different architectures and do some handful code. So that was a plan. We have done with artificial neural network. We have done with a variant of LSTM, that's your GRU implementation has been done. Then we have stepped into HMM. We have shown you a possibility of looking at malware analysis using hidden Markov model. Last part, what I have left you as a thought process would be is where people are now using malware with images. So can you think of images, train the model using deep learning, give images which has malware, see how do they vary from the original images and say that malware is detected if it is an image part, right? That's all from my side. So any questions, I'll be able to answer.
That's all, Mr. Master.
Any questions, participants? You can ask, sir. You can unmute yourself and ask, sir.
Hello, sir.
Yes, madam, please.
Sir, what had happened is, after creating a baseline model, the baseline model was giving a good accuracy, sir. And
Okay.
when applied with the transfer learning or higher deep learning models, so it is going bit low. So what could be the possible reasons for that, sir?
Ma'am, baseline model is created with which architecture, ma'am?
With normal sequential architecture, sir.
Sequential architecture, right?
Yes.
Then you are going for transfer learning, no?
Yes, sir.
Okay, transfer learning, what architecture you are using, ma'am?
So just the basic architecture I have started, sir. So still not yet explored. I was just playing around with that, sir.
Okay, so what I would suggest you is, ma'am, like now it's right time that you can actually go back to your basic CNN that you have tried.
So sorry, sir. Come again,
What is
sir.
your deep learning architecture that you have tried, ma'am?
Sir, I'm not able to hear you.
Ma'am, I'm getting some audio from the background. Somebody is.
Exactly, sir. Same.
Uh, yeah. Now my question is clear, ma'am. What is the architecture that you have used in the baseline model?
Okay, sir. Sir, it's a normal sequential model only. I have used it, sir.
Sequential is okay, ma'am. Are you going to CNN or LSTM,
No,
RNN?
no, 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 sir. No, not yet, sir. So just started up with logistic regression. So that part alone, sir.
Okay, see, ma'am, again, since you're bringing keyword of logistic regression, you will have to come back and ask your data whether it is having a continuous distribution in the data part. If it is having a continuous distribution in the data, then you can go for logistic regression.
Right, right, sir.
Right, ma'am. If it is not having a continuous distribution, then you have to go for either an approach of machine learning or you have to come to deep learning. So what I would suggest you is first you put a ground truth understanding, conclude regression is yes or no for your problem. Okay, ma'am. Then second thing is you can try to formulate it with CNN, right?
Okay.
Convolution neural network, and then you can try to compare it with transfer learning.
Okay. Okay, sir. Okay.
Right,
Got
ma'am?
it, sir. Got it. Clear, sir. Clear. Thank
If
you,
it
sir.
is to be malware, it's better to go for any variants of LSTM because it's a sequence data, right? So
Correct.
naturally, you can go for a memory architecture which will consume more, which will be able to take larger memory data but give you better representation. There you
Okay.
can go for variants of LSTM or LSTM itself.
Got it, sir. Got it. Got it. Thank you,
Yeah,
sir.
yeah, thank you, ma'am. Thank you. Any other questions from the participants?
Any other questions from participants? Please, you can ask sir the questions. Please unmute yourself and you can ask the questions.
Okay, going forward, I'm repeating the point. If you get stuck with creating a log, so I suggested you on the other day itself, you can set up a honeypot, right? You can set up a honeypot. You can simulate attacks. There you can simulate attacks relevant to malware, and then you can generate your log, right? One that I've been showing you is take data set from Kaggle or take data set from IoT botnet like that. Other possibilities, you can set up a honeypot. You can generate attacks. You can try to take the signatures of the logs, right? There you can actually say that this is my data set. This is my set of attacks that I have developed in my environment. That's also a good way of doing, right? Any more questions from the participants?
Participants, any more questions?
I think it's a big silence. So getting close to weekend, I think everybody's on the weekend side. Anyway, so my sincere thanks to the organizers, and thanks to Manju ma'am, thanks to your principal, Singh sir, and team of your institution, Gopalan Institutions, for accepting myself to be part of your sessions. And the participants, I leave you my mail ID. Please get back on mail if you have any specific questions. Surely, if there is some challenge that you face in working with malware analysis or deep learning or transfer learning, please write me a mail. Surely, I will try to give you my support, whatever I can do with myself, which is possible. Okay? Thank you so much, and I keep my sincere thanks to my PhD guide, Dr. San Shivanandam sir. He is my professor, and who has elevated me to what I am today. And he was PhD Tech, Coimbatore as former professor, and he is known to most of the institutions. And he is one who brought me into this area of machine learning and deep learning. And today, my strength, if you ask me, it's because of my PhD guide. So, my credits to my PhD guide. Thank you all for your patient listening.
Thank you, sir. Thank you for this wonderful session and giving us the insight of different areas in research in malware. And thank you so much for lot of information. Thank you so much.
Thank you, ma'am. Thank you all. Be safe. Have a happy weekend. Thank you.
Yeah, sure. Same to you, sir.
Yeah, thank you.
Participants, you will be having the validatory session now. I will hand over my session to Ms. Shilpa. Please wait. Hello, dear participants. Shortly, we are going to start validatory function. Stay on for another 10 minutes. Feedback link is posted. Kindly give a feedback. And also test link is, we are going to post test link now and the link will be open till 8 o'clock.
ನಾನು ಟೆಸ್ಟ್ ಲಿಂಕ್ ಜಿಮೇಲ್
Am I audible?
Yes, ma'am.
Yeah. Good evening to one and all present here. I extend my warm welcome to you all for this valedictory function of Phase 2 AICT sponsored online short-term training program on cyber criminology and network security organized by Department of CSE, Gopalan College of Engineering and Management. I would like to focus on highlights of AICT sponsored online STTP on cyber criminology and network security. On this auspicious day, the first day, the two sessions were conducted and it is followed by Mr. Sanjay Saha. The topic he delivered is about cyber security, the biggest challenge of digital transformation. Dr. Avinash Sharma, the topic is about digital forensic open source tools. Dr. Muruganandam, artificial intelligence, cyber security. Narasimha Rao, topic cyber security issues and challenges. On third day, Clara, the topic is cyber security, forensic and cyber laws. And Mr. Sanjay Kumar, the topic is recent crime trend and research methodology. On fourth day, Dr. Senthil Kumar, and this topic delivered is malware signature analysis and classification. And Dr. Nilanjan Day, topic is about forensic digital image processing. On fifth day, Dr. Anant Prabhuji, the topic find anyone using OSINT, and that day afternoon session is conducted by Dr. Avinash Sharma, practical cryptography techniques, symmetric and asymmetric. And the last today, the morning session was conducted by Dr. Prakash. The topic is redefining cyber security vision for the new normal working strategy. And afternoon session was given by Dr. Senthil Kumar. The topic is about malware signature analysis and classification. Each session was followed with question and answers, and all the lectures were being concluded strictly on time. Morning session started from 10:30 to 12:30 and afternoon session started from 2 p.m. to 4 p.m. Around 200 participants registered for this event and around 100 participants participated from all over India, and they have taken actively participated throughout this STTP. At end of each day, feedback link was posted and participants have given their feedback. And we are also happy to declare that we have received so many positive and excellent feedback from our participants. With this highlight, I conclude a brief summary of this SDTP. Now I request our program coordinator, Dr. M. Pauline Ma'am, to felicitate the gathering.
Yeah, thanks, Shilpa. Yeah, good afternoon to all. So I hope all the participants had a nice knowledge, or they gained a great knowledge. And thanks to all the eminent speakers who have shared their knowledge, and the participants benefited by it. And I also take this opportunity to congratulate all the faculties of CSE Department, Gopalan College of Engineering, for making this program happen. Thanks to one and all. Thank you.
Thank you, ma'am. Now I request our HOD, Dr. Somshekar sir, to propose vote of thanks.
Yeah, thank you, madam.
Thank you, sir.
So, good evening to everyone. On behalf of Department of CSC, Gopalan College of Engineering and Management, and the entire team of AICT STTP, I may like to express my sincere thanks to the management for supporting and cooperation towards conduction of STTP. And also, I would like to thanks to STTP coordinator, Dr. Pauline Madam, and our co-coordinators Manju Madam for valuable support towards conduction of STTP with great success. And especially for any STTP or faculty development program, so it depends on the resource person lectures, which are very important for delivering valuable things. And in our case, so I would like to sincere thanks to the resource persons or keynote speakers. They delivered excellently in all the sessions. So that's why I would like to say thanks to all the resource persons for accepting our request and immediately responding for our queries also. So especially all the resource persons, namely Dr. Ananta Prabhu, Sanjay Saha sir, Avinash Sharma sir, Dr. and Dr. Murugananda and Mr. Nasimha Rao sir and Dr. Clara and Sanjay Kumar sir, Dr. Senthil Kumar, Dr. Prakash, Dr. Neelanjan Dev. So all the resource persons having very high profiles and really so happy to accept our invitation immediately without any further discussion and presenting their valuable knowledge and sharing their knowledge to the participants. So that's why once again thanks to each and every resource person. So all the profiles are very high. So that's why we are really, it's a great pleasure to accept our request and presenting their knowledge or sharing their knowledge to the participants. And coming to the next one, so our faculty team. So each and every faculty member starts from Manju Madam, Silpa Madam, Supati Nair Madam, Aparna Madam, Arvind Sir, Suparna Madam, Mallesh Sir, and Giri Sir. All are cooperated nicely for conduction of this event successfully, along with our technical team, Yogesh and Raghavendra and Manju. So these people also helped a lot for conduction of this event. So in time and successfully completed. So because of these people hard work towards conduction of this STTP. And last but not least, so I thanks to our principal, Dr. Sengotian, for his cooperation and support towards conduction of STTP. So because whenever we have any issue regarding resource persons, etc., so we used to communicate to the sir and we used to request, this is the issue, sir, or maybe any sessions postponed or preponed, we used to ask. Immediately, sir used to give suggestions, or maybe sir used to provide other alternative resource persons. So that's why really in that aspect, he helped a lot for conduction of this STTP. So that's why on behalf of entire faculty team of CS department, so thanks to principal sir for cooperation and support towards the STTP. So last but not least, so my heartful thanks to the all participants for your actively participation and response towards the questions from the resource persons or maybe faculty members immediately, and you are giving nice responses even through WhatsApp group also. Even any queries you are putting means it is helpful to improve the quality of our STTP. Sometimes you are giving some comments like some sound is not good or maybe another technical issues. Obviously these are very helpful to improve the system. So that's why my heartful thanks to all the participants for your support and encouragements towards conduction of this test TPP, and we are looking for same cooperation in future events conducting Gopalan College of Engineering and Management Department of CSC. So once again thanks to each and everyone so for your support and encouragement towards conduction of STTP with grand success. Thank you one and all.
Thank you, sir. Now I request any of the participants can share their view about this event. Anyone from participant side? You can unmute yourself.
Yes, ma'am. Good evening, all. My name is Apurva, and I'm from Jain University doing part-time doctorate research in the field of digital forensics at NIT. And this, I first of all, I thank Gopalan College for giving us the opportunity because all the lectures were very well aligned with the topic. As like cyber criminology and network security, it was very well aligned. And in fact, I personally, and myself, I'm very much satisfied. And actually, I got to know about this. FDP from one of my ex-colleagues, and I immediately actually I replied to her that ma'am, it is really good, it is worth attending it. So I once again thank you, and I hope we get still more related webinars or STTP or FDPs pertaining to cyber security or cyber criminology or digital forensics, and the selection of speakers was excellent. So thank you Gopalan College for this opportunity.
Thank you, ma'am, for your valuable feedback.
Yes.
Thank you so much, ma'am. Any other participants want to share your feedback?
Good evening, ma'am. Good evening, ma'am. My name is Seena Elizabeth Matthew. I am from Presidency University. First of all, thank you so much for allowing me to participate in this workshop. It was very informative, ma'am. So thank you so much, ma'am.
Okay. Thank you so much for your feedback. And I once again wholeheartedly thank all the resource person and participants for making this STTP a successful event. And I hope that you all will take away most of the essential points that have been delivered by our distinguished speakers. By this, I thank you all once again, and we will be looking forward for your presence in upcoming events. Thank you once again. Thank you all.